Hello everybody. Now we will see a presentation about Selinon distributed computing with Python.
So thank you. My name is Selinon.mp4, and as said, this presentation will be about distributed computing with Python. And let's have a look at the agenda. So first I will talk about Celery. Celery is quite a popular project. If you don't know it, I will discuss some basics. Then I will show some pitfalls you can find with using Celery and basically why Selinon was developed. I will show you the key idea behind Selinon and also some experiences with Selinon I've got. So Celery is quite a popular project. You can find it on celeryproject.org. It was written by AskSolem, and he's the current maintainer as well. Celery is a distributed task queue, so you can run your task written in Python distributively, and it's quite widely used. For example, it's used in Django as Django Celery for background tasks. So how does Celery work? As in any distributed system, we have some kind of message that describes what should be computed and the arguments. We queue this message into a message broker, and we queue it in message broker, and there are connected some workers to this message broker. Every worker listens on some particular queue, and once there's available worker and there's message queued, some worker picks that message and starts to execute. As we are in distributed system, there can be multiple messages queued, so when there's available worker, it starts to processing it. There's also result backend. This result backend is used for storing results of tasks and also for storing state of tasks. So once a message is processed, there's written result to result backend, and the worker is available again. The same applies for the worker 1. So this is the key idea behind Celery. Now let's discuss some flows. In the real world, you have some tasks that have time or data dependencies between them. So let's model something like that. We have 6 tasks, and there are dependencies between these tasks. And these dependencies are as shown in the picture. So with Celery, there are some Celery primitives that allows you to group tasks into some primitives like group, where you can execute tasks in parallel, or chain, where you are executing one task after another. So in our flow, we have these dependencies. Let's say that these tasks have various execution time. That means there needs to be, for example, 1 minute to process that task. If we use Celery primitives, we grouped it into a chord, and we can run task 1 to task 4 in parallel, and task 5 and task 6 in parallel. As you can see, the first chord takes 30 minutes to process, and the second, it takes 10 minutes. The result of task 5 and task 6 is available after 40 minutes. And if we can do better, we can, by removing these chords, we can find our result after 31 minutes in case of task 6, and in case of task 5, we can find it after 40 minutes. So we are no longer blocked by tasks that take a lot of time. Also, when you use Celery, there are some downsides, like you are hard-coding your task logic and dependencies on these tasks into your source code. So adding new tasks, it's complex. A lot of times, you just have to reorganize your task and dependencies between them. And what about task failures? If a task fails, we want to recover somehow from this failure. We also want to reuse these tasks, and we don't want to be blocked by using one storage at a time. So that's how Selinon was introduced. Selinon means celery in Greek, Greek is quite popular with naming distributed systems such as Kubernetes, so I picked Selinon. And what Selinon offers you, it offers you to separate flow logic from your task logic. That means you implement a task, and then you provide a configuration, a simple YAML file, which states how these tasks should be grouped. It also allows to model dependencies between these tasks. It also allows you to use different storages and also to do something like recovering from failures. So let's take a look. Here's an example of Selinon task. You just import Selinon task, you derive from it, and you provide a method that is called run, and that's the input of the task. Then you return your result. That's all. Then you provide the YAML configuration file. Let's say we have 3 tasks, and in this YAML configuration file we state, hey, we have these tasks, so you provide a list of tasks, you provide an import where these tasks should be, where the implementation of tasks sits, you provide a name of the task, and you also provide optionally queue where this message should be queued. Then you provide flow definitions, so you name your flow, and you give edges. So basically a flow is described by edges. As in example, there's started task 1, we don't have source, so the task 1 is run initially, and then after the task 1 is done, we run task 2 and task 3. You might be wondering what are these octagons on the picture. These octagons are conditions. So what Selinon allows you, it allows you to state conditions and execute task conditionally. So for example, let's say we want to run task 2 and task 3 after task 1, and we give condition like, hey, I want to run if field is equal, that means the result of task 1, has key proceed, and this key has value yes. Or if there's some environment variable, and this environment variable is named testing. So by providing this condition, we have conditional execution. As you can see, you might be wondering, okay, we provided a condition and we are inspecting the result of task, but we didn't provide a way how to say, hey, I want to store some result into a storage or database. Selinon offers you this as way. What you need to do, you just need to provide a definition of database adapters. So for example, if you want to use Redis, you just provide, hey, how to connect to a database, how to retrieve a result, or how to store a result from database. Then you provide this definition into your YAML configuration file, where you state where the implementation of database adapter sits, and what is the name. Optionally, you provide a configuration, and then you assign these storages or databases to your tasks. And as visualized, these results are stored in Postgres or Redis in this example. Now, we want to have some granted control in our flow, so we want to have something that will give us a way how to recover from failures, and this can be done using fallback task or fallback flows. The configuration is pretty straightforward, so in your flow definition you provide failures, and you state, hey, if nodes task 2 and task 3 at the same time fail, I want to run fallback 1. Another failure could be that only task 2 failed, and in that case we want to run fallback 2. If we visualize it, we can see that if task 2 and task 3 failed, we run fallback 1. In case of task 2 failure, we run fallback 2. Now, in many cases, you want to reuse this, so you want to run some flow from another flow. Selinon offers you subflows, and it's pretty straightforward. As a flow is another node in your dependency graph, you can directly state your flow in your YAML configuration file, like this. So after, in this particular scenario, after the init task is done, we can run flow 1. After that, we run flow 2. And now you might be wondering, how does Selinon work? The key idea behind Selinon is a special task that is called dispatcher task. And this task basically is scheduled on some nodes, and it periodically checks the state of the flow. So we have a dispatcher that is dedicated for each flow, and it checks the state of the flow, it checks which task failed, which task succeeded, and it schedules a new task if needed. You just provide YAML configuration file, and this YAML configuration file is automatically parsed. There are also some additional checks that your YAML configuration file is correct. There's also a way how to visualize flows, so you can just provide your YAML configuration file, and Selinon will give you these graphs as shown on pictures. There are also other features like caches. If you don't want to receive a result of a task every time, you can use Selinon caches. Also, there is a way how to use cache for retrieving the status of task. You can also do task or flow throttling. You can say, for example, hey, I want to run these tasks no more than 2 times per minute. Selinon allows you to do that. You can do also task prioritization, like, hey, I put a lot of workers that listen on some queue, and this way you can prioritize tasks. There's also a way how to optimize dispatcher scheduling, so you can schedule dispatcher, for example, once after 2 seconds, or you can do it after 5 minutes. There's also a trace point mechanism where dispatcher will tell you what's going on in the system. So you can, for example, inspect what's going on in the system, and you can do it by inspecting JSONs that provide some unique keys, such as dispatcher ID or tasks that were run, and you can listen on some particular events, such as scheduling new flow, scheduling new task, or retrieving results or failures. So to summarize it, Selinon is built on top of Celery. It uses Celery to communicate with broker. It provides you a way how to easily define your tasks and flows just by providing YAML configuration file. It allows you to separate task logic, so you have Python code, and then you have logic of storing tasks, and it allows you to conditionally execute some task, group task into flows, and it offers you advanced flow handling, so you can recover from flow failures, and you can do system diagnosis by trace points. This is an example. Selinon is currently used at Red Hat, and here is an example of flows that we have. As you can see, they can be complex, and they can be nested one inside another, so things may be quite hard to understand at the first point. So that's it from me. You can find Selinon on GitHub. If you have any questions, feel free to ask. So the question was how to do throttling, like we want to execute a lot of tasks in parallel, but we want to have throttling mechanism available. So there's a trick to do that. You can schedule dispatcher on one particular node, and this node will take care of how many nodes are being executed. So that's it. Another? Sorry?
On the failures and fallbacks that you were showing, you said you had if task 2 and 3 fail, fallback 1, if task 2 fails, fallback 2. So there's no results from both, or
So I don't know if so the question was regarding fallbacks.
yeah, so if task 2 finishes before task 3 and fails, will it go to fallback 2 or will it wait for 3 before it decides to wait?
So the question was if there's some dependency between task 2 and task 3 failure, and when the fallback is run. So in this particular scenario, Selinon will take care of it. It will wait for all tasks to finish, and after they finish, they will look, hey, I have some failure, and if I can recover from it. So if task 2 fails, and task 3 is still running, we wait for task 3 to finish. Any other question?
So you mentioned how with Celery it's difficult to add tasks and they're all hard-coded. Does this also inherit the fact that your actual logic is still hard-coded on your workers, or does this provide the ability to give them new tasks dynamically?
I don't know if I understood it correctly. Can you repeat it like louder or?
Basically, is it possible to provide new task logic dynamically, or do you still have to hard-code that for workers?
Okay, so the question was if we can add task dynamically, like you have deployed your system and we want to add task dynamically. No, you cannot do this. It's not possible. Yeah? Yeah, go on.
I want to register every time a task fails or succeeds, and maybe the result is only to some database or something. How would you do that?
So the question was about failures, and I didn't hear.
How would you register every time a task is fails or succeeds? I want to monitor it for other things.
So the question was, how do we monitor, like, if task fails or so? This is reused from Celery. So when a task fails, it basically states the failure state in a result backend, and then you have a mechanism how to ask what was the state, and based on the state we proceed with fallback. Yeah, we query it. Any other question?
How would you use this in a Django project?
The question was?
How do you use this in a Django?
I don't use it in Django. It's like a distributed system where we run OpenShift, and there are nodes, and these nodes are communicating with Selinon.
You don't have anything yet to integrate it into a Django?
No, there's no Django integration. Any other question? So, okay, thank you.